Hi everyone, welcome to AI Crack channel. This is Akash Kangar and today we'll be starting circles lecture 1. So basically we are starting out with conics and along with circles we'll also be doing parabola, ellipse, hyperbola parallelly with circles. Okay. So let us start our first lecture with the definition of circles just like straight lines. So it is the locus of a point which moves in a plane in such a way that its distance from a fixed point is always constant. So let's say this is a fixed point called P and let's say this distance is R and this variable point is H comma K. That is, standard format for locus. Now, if we keep on moving this point, whereas where we are keeping this distance as equal. So if I move this point along this path, then I'll be getting a circle. It's a poor diagram, but this is how a circle diagram would look like if we draw it with the help of a locus definition, right? So basically, we are at all these points, the distance from point P is equals to R, and that would create a trajectory that is called as circle. Okay. Now let's talk about the general equation of circle. You must have seen circle in the format of x square plus y square equals to a square, but that is a very specific form. Let us talk about the general equation of circle. So for that, what we'll be doing, let's say we have this point x1 comma y1 that is the center of circle, and this distance, constant distance r as the radius, and this variable point is h comma k. So basically we are defining it from basics of locus. Okay. So we'll apply the condition of locus only. What is the condition of locus? That this distance r is same. So we'll apply the distance formula, h minus x1 whole square plus y minus y1 whole square equals to r square. So basically this distance is staying common and we have applied the distance formula. Now if you want to find out the final equation of circle, general equation of circle, we'll be replacing h with x in this is k and k with y, right? So that would give me x minus x1 whole square plus y minus y1 whole square equals to r square. So that would become x square plus x1 square plus 2 minus 2x x1 plus y1 y square plus y1 square minus 2y y1 minus r square equals to 0, right? So if we take these variables together, that would give me x square plus y square minus 2x x1 minus 2y y1 plus x1 square plus y1 square minus r square equals to 0. But this equation looks very shabby, and for any generic equation we cannot convert that equation into this format to find out the value of center and radius. We have to do certain kind of modifications. So we'll first write the generic equation. So basically we have the term x square, we have the term y square, and we'll use this format 2gx plus 2fy plus c equals to 0. So basically this is our constant term c, and we have removed these minus sign from here to write in this particular format x square plus y square plus 2gx plus 2y plus c equals to 0, and this is the standard format of a generic circle equation. But we actually derived it like this only, so we have to convert, we have to find out the relations between g and x1 f and y1 c and this part. Okay. So our main parameters for any circle is center and radius. So we have to find out radius and center with the help of this equation given. So initially we had a center at x1 and y1, and we got the coefficient of x as minus 2x1. But now in this generic equation we have written it as 2g. So basically center would now be, to make this x1, center now would be minus g, right? For x1 it came out to be minus 2x1. For 2g it would be minus g, right? Because we have 2g over here, the center would be minus g, right? Similarly, the second part of the center would be basically y coordinate of center would be minus f. This part is clear because for x1 we got minus 2x1, but now we have removed that sign, we have replaced it with plus sign. So that is why we have to incorporate one minus sign to find out the center value. So this is our center. Now if you want to find out the radius, this equals to this constant. So x1 square plus y1 square minus r square equals to c. Now we can replace x1 with minus g and y1 with minus f. So that would give me g square plus f square minus r square equals to c. So this gives me r equals to under root g square plus f square minus c. So these two formula you have to remember for every circle. Minus g minus f would be the center, and g under root g square plus f square minus c would be our radius. Okay. Now let us look at this question. The locus of the center of a circle of radius 1 unit which rolls on the outside of the circle x square plus y square plus 3x minus 6y minus 9 equals to 0. Okay. So with the help of the general equation formulas minus g minus f and under root g square plus f square minus c, you can find out the value of coordinates of center and the radius. Okay. So minus g comma minus f, that would be minus 3 by 2 comma 6 by 2, that is 3. So this is the center. This is the center. If you want to find out the radius, that would be g square plus f square plus minus c. So this would be 9 by 4 plus 9 minus of minus 9. So this would become 18 and 18 4 72 and 81. So that would give me 81 by 4, that is 9 by 2. So the radius is 9 by 2. Now the given condition is we have this center C and this radius 9 by 2, and there is a circle of radius 1 unit. So this is the circle of radius 1 unit and it is rolling on the circumference of this circle. Okay. So basically we have to find out the locus of the center of the circle. So this is nothing but another circle because it's rolling on this particular circle with an additional distance of 1 unit. So this radius would be 9 by 2 plus 1. So that would be 9 by 2 plus 1. That is 11 by 2, right? So we have got the radius, we have got the center, we can find out the equation. So that would give me x plus 3 by 2 whole square plus y minus 3 whole square equals to 11 by 2 whole square. With this, you can find out the answer. Now let us talk about the equation of a circle passing through three non-collinear points. So let's say we have this circle, this point is A, this point is B, and this point is C. This is x1, y1, this is x2, y2, this is x3, y3. So to solve this, what we'll be doing, we'll be writing the general equation of circle x square plus y square plus 2gx plus 2fy plus c equals to 0. Now we'll be putting these points in this equation. We have three variables g, f, and c, and we'll be getting three equations. If I put this value over here, this value over here, and this value over here, we'll get three equations in g, f, and c, and we can find out the value of g, f, and c, and find out the basically eventually that equation of circle. Okay. Now let's look at this example. If the vertices of a triangle are 2 comma minus 2 minus 1 comma minus 1 and 5 comma 2, then the equation of the circumcircle is. So we have that kind of question only. So the general equation is x square plus y square plus 2gx plus 2fy plus c equals to 0. So basically we'll put the value of this first coordinate, that would give me 4 plus 4 plus 2g times 2 plus 2f times minus 2 plus c equals to 0. So this gives me 8 plus 4g minus 4f plus c equals to 0. So this is our first equation. Similarly, we'll get the second equation, that would be 1 plus 1 plus 2g, sorry, minus 1 minus 2g minus 2f plus c equals to 0. So this becomes 2 minus 2g minus 2f plus c equals to 0. This is our second equation. Similarly, you can find out the value of find out the third equation in g, f, and c. This is the first equation, g, f, and c, and you can solve it for g, f, and c. But the main point over here is this is the very standard method, and in examinations most of the time you don't have to use this method particularly. Why? Because in most of the cases the points given are usually either right angle triangle or isosceles triangle or equilateral triangle. So basically a favorable kind of triangle where you can find out the value of circumcenter pretty easily. So in most of the cases they'll give this kind of situation only, and you just have to identify what kind of triangle this is. You don't really have to make three equations and three variables. This is just for the illustration purpose, that in the worst case, if you don't find any favorable triangle over here, then you have to solve it in this manner. But in most of the cases you'll get a favorable triangle and you have to find out the circumcenter accordingly, and you don't have to do that kind of slogging. Now let's look at this example. The center of a circle passing through the points 0, 0, 1, 0 and touching the circle x square plus y square equals to 9 is. Now this equation is the very standard format of equation, right? So we can write it like x minus 0 whole square plus y minus 0 whole square equals to 9. So basically r equals to 3. It's of the format x square plus y square equals to r square. R equals to 3 over here, and center equals to 0, 0 over here, right? Now if we try to draw the diagram for this question, So this is the circle which is being given, and this point is 0 comma 0, this point is 1 comma 0, and this point is 3 comma 0 because of the radius. Okay, now one circle is also drawn, something of this sort. One more circle can be drawn towards this side, but just to make the diagrams more clearer, we'll do it in this manner only. Okay, now if I, this is the center of the bigger circle. If I join this point and this touching point, then this would be the radius of this bigger circle, but also this would be the diameter of this particular circle. Why? Because at the point of touching, you can say for sure that it will have common tangent, and if it is having a common tangent, then this would be perpendicular to it, and in this case this should be passing through center for it to be perpendicular to this tangent, right? So that makes it very clear that this particular line is the radius of this bigger circle and also the diameter of this smaller circle. Okay, now if this is the diameter of this smaller circle, so and radius of this bigger circle is 3, so diameter would be 3 of the smaller circle would be 3, so radius of the smaller circle would be 3 by 2. So that is the most important part, that radius is 3 by 2 for the smaller circle. Now let's say this point is x comma y. Now with the help of distance formula, if I join this line, distance of xy with 0 and distance of xy with 1 comma 0, that should be equals to radius, and technically both of them should be equal, right? So x square plus y square equals to 9 by 4, that should be the first equation for this one, and the second equation would be basically equating these two distances, that would be x square plus y square equals to x minus 1 square plus y square. This gets cancelled out, so that would give me x equals to half only. In only this case this would be possible, right? Now if x equals to half, we'll be getting 1 by 2 whole square plus y square equals to 9 by 4. That gives me y square equals to 2. So basically y equals to plus minus 2 raised power 1 by 2, right? So basically D is the correct answer. So in this question, the main idea was about identifying that this particular radius would also be the diameter of this smaller circle, and that would solve our question. Okay. Now let us talk about the diameter form of the circle. Let's say we have this circle over here and this is the diameter. The endpoints of diameter are x1, y1 and x2, y2. And let's say this point is h comma k. Okay. Now we know the property that if we draw a triangle connecting the endpoints of diameter, that would subtend a 90-degree angle at the circumference, right? So this would be 90-degree. So now we can use one property, that product of this slope and this slope should be -1. That's a simple property of perpendicular lines, right? So basically k minus y1 divided by h minus x1 multiplied by k minus y2 divided by h minus x2 equals to -1. Now if I do the cross multiplication, I'll be getting k minus y1 k minus y2 equals to minus times h minus x1 h minus x2, right? Now if I take it towards the left, I'll be getting k minus y1 k minus y2 plus h minus x1 h minus x2 equals to 0. Now if I replace h with x and k with y, I'll be getting x minus x1 x minus x2 plus y minus y1 y minus y2 equals to 0. So this is the diameter form of equation of circle. Okay, it's pretty simple to understand. Only thing you have to do is, if you have been given 2 points of diameter, 2 endpoints of diameter, you just have to write the equation in this particular format, and you will get the equation of circle. Okay. Now let us do one question based on the same concept. Line 3x plus 7y equals to 21 meets the axis at A and B. Find the equation of the circle through OAB, where O is the origin. So this is our coordinate axis. Now I'll write this equation, straight line equation, in the intercept form. That would give me 3x by 21 plus 7y by 21 equals to 1. That becomes x by 7 plus y by 3 equals to 1. So basically the x intercept would be 7, and this point would be 7 comma 0, and y-intercept would be 3. That point would be 0, 3. So this is my line. Okay. Now we have to find the equation of circle just passing through these 2 points. Let's say this point is A, this point is B, and this is O, and this origin O. Interesting point over here is coordinate axes are at 90 degree, and this point is passing, origin is passing through the circle also. So basically A and B is the diameter. AB is the diameter. Now we can use the diameter form over here. So that would give me x minus x1, that is 0, x minus x2, that is x minus 7, plus y minus y1, that is 3, and y minus y2, that is y minus 0, equals to 0. So this would become x square minus 7x plus y square minus 3y equals to 0. So this is the equation of our circle. So today's lecture was till here only, and in the tomorrow's lecture we'll be talking about more concepts of circles and its properties. So let's see you tomorrow. Thanks for watching.